All right, I'm going to talk about the basics of recursives. So I'm going to talk about the basics of them and how they all work. So few important things. So first off with arithmetic, the first and probably one of the most important thing is you need to tell what is A1. So tell what A1 is, give a starting spot. Because recursives more focus on what is the pattern and how do you develop sequences. So for our purposes, we have an equals an minus 1 plus d. That is the rule, or recursive rule, for arithmetic sequences, with d being what you add and subtract every single time. Again, the reason we need a is, if I said, all right, I'm going to have a sequence where we add 3 every single time, well, add 3 to what? I need somewhere to start so I can develop the rest of the sequence. Same thing with geometric. We always need to know what is the first term. That way, if I say multiply by 2, well, multiply what by 2? I need somewhere to start to develop the rest of the sequence. So you're going to need a1 equals something, and an equals r times an minus 1, where r is whatever your multiplier is. So first example here is we're going to look at, well, using a basic arithmetic sequence, what does it look like for the first 4 terms? So they always give you a starting spot. So they tell me a1 equals 3. And then this is the key for developing future terms. So for example, if I know a1 is 3, say I want to know a2. So I'm going to plug a 2 in for n. So a2 equals, we'll have a2 minus 1, which is a1 plus 7. But here's the deal. What do I know about a1? Well, I just said a1 is 3. So really a2 is 3 plus 7, which adds up to 10. So a2 is 10. So then I can keep moving on. If I want to know the third term, I'm going to plug a 3 in for that n. So 3 in for this end, so 3 in for this end. So I'll have 3 minus 1, which is a2 there, because again, 3 minus 1, I get 2, so I put a2 plus 7. But what do I know about a2? Well, I just said a2 is 10, so I have 10 plus 7. So I get 17. And then finally, if I wanted to know a4, it would look like a4 equals a3 plus 7. Well, you find the previous term, add 7, and we're going to end up with 24. So the first 4 terms there are 3, 10, 17, 24. So that was an arithmetic sequence. Notice how I had this piece, the plus 7. And when you add 7 every single time, that's an arithmetic type sequence. So moving on to a geometric one. They give you a1 is 120, so I know my first term, so that's a good start. But if I want to know future terms, I'm going to take an equals 1/2 times an minus 1. So if I want to know a2, so I replace my n with 2, I'm going to have 1/2 times a2 minus 1 is a1. So 1/2 times a1, which is 1/2 times 120, which 1/2 of 120 is 60. So my second term is 60. If I want to know the third term, it's going to be 1/2 times, well, an minus 1, but in this case, n is 3. So 3 minus 1, which is a2. So 1/2 times a2. Well, I just said a2 is 60, so 1/2 times 60 is 30. And then I move on to a4, which is 1/2 times a3. So that's 1/2 times 30, which I get 15. So I just took everything and I multiply it by 1/2. So 120 to 60 to 30 to 15. One more example that deals with the basics is I'm going to write the recursive rule for 19, 23, 27, 31, this sequence. So again, 2 important things I need. I need to know a1, and then I need to know what d or r is. Depending on d or r, that's how I know which of these 2 sequences or rules I'm going to use. So looking at this one, it's again, we're back to recognizing patterns. So how do I go from 19 to 23 to 27 to 31? Hopefully this one's pretty easy to pick up, and it's add 4 every single time. So again, the 2 important pieces, I need to know what a1 is, and I need to know what d or r is. In this case, it's d because we added 4 every single time. So I know d is 4. a1, my first term, is 19. So if I want to put the recursive rule together, I needed two things for arithmetic. I needed to know A1 and then use this, but plug in and replace D. So I'm going to leave alone the AN and the AN plus AN minus 1. I should replace A1 and D. So my rule, I'm going to write it in red here. This would be your answer is A1 equals 19 and AN equals AN minus 1 plus 4. So that would be your answer. And this is an arithmetic one. So let's, final example here in this video, let's look at the geometric one. So I kind of gave it away. It is geometric, but we're going 3 to 12 to 48 to 192 to 768. Again, I need to know what A1 is. Well, that's the first term, it's 3. And I need to know what DRR is. Obviously, this is getting big fast, so I know it's R. To find an R, an easy way is take the right term, divide it by the left term. So right would be like 12 divided by 3, which is 4. So I know A1 is 3, R is 4. So the recursive rule, we always state, hey, A1 equals 3. Give me something to start with to build off the sequence. And then for the geometric recursive rule, it's going to be AN equals R, which we had 4, times AN minus 1. So that would be the recursive rule for a geometric, a recursive rule for the arithmetic, and that is your basics of the recursive rules.